In the heat of the Cold War in 1964, amidst the echoes of the Cuban Missile Crisis and the nuclear capabilities of the Soviet Union, Britain, and France, the US government contemplated a critical question. How easily could a technically competent nation with no explicit nuclear weapons knowledge develop a nuclear device? At the heart of this question was the fundamental debate. Was there a secret to constructing a nuclear weapon reserved only for brilliant minds like Teller or Fermi? Or was it a technical issue, a puzzle that could be resolved with enough determination, talent, and a modest level of funding? Scientists at the Lawrence Livermore National Lab believed that there was no secret and that it could be done without Nobel laureate talent. The lab had been improving weapons design since 1952 using young physicists out of the Rad Lab in Berkeley. But there were others who doubted this and believed that the problem would be too difficult to solve without exceptional talent like the minds at Los Alamos. To settle this debate, Lawrence Livermore National Lab created the Nth Country Experiment. The lab hired two physicists, Dave Dobson and David Pipkorn, although Pipkorn left the project a couple of months later to be replaced by another young physicist by the name of Bob Selden. They had a couple of very interesting interviews. They kept getting asked questions around nuclear physics and chain reactions. According to reports, their interviews did not go well, and the candidates went home discouraged. Dobson was reportedly unaware of gun versus implosion design and had limited knowledge of nuclear fission. But to their surprise, they got the call for the job. It turns out they were exactly the candidates fit for the job in that they were physics graduates, but with no expertise in nuclear physics. The duo started the project and set out to research. They were allowed all manners of unclassified and public information. They were even allowed to have contact with members of the Lawrence Livermore National Lab and request calculations to be run. However, they were not allowed any classified information. According to Dobson, they simply went to the library and looked up literature under plutonium, uranium, and high explosives. An especially helpful place for research was any kind of university library with a mines and engineering school, as they tended to have a large amount of literature on all manners of explosives and shaping. They also went to conferences to talk to experts. 7 months into the project, they made a choice to go for an implosion design rather than the simpler gun design. When asked why they did this, Dobson reveals that this was primarily done as an intellectual challenge that a young physicist could build their career on. There was also the fact that the implosion designs give a larger bang for the material. That is, nuclear material is precious, and you want to maximize the yield as much as you can. A gun design would be far simpler with less yield and less bragging rights. Soon after, Pipkorn left the project and Bob Selden joined. In an ironic twist, President Eisenhower's Atoms for Peace program became a significant resource for the duo. Intended to promote non-military benefits of nuclear power, the initiative inadvertently released a wealth of nuclear information into the public sphere. The team also discovered a priceless resource in their lab's library. In the unclassified section, there was data meticulously collected by the researchers from Los Alamos. The detailed information, especially data on critical mass, became crucial in their work. Also helpful were Hugh Paxton's contributions, which allowed them to calculate the amount of plutonium needed for their design. This unexpected resource substantially fast-tracked their project. Dobson and Selden ran their numerical simulations on a punch card computer, which, while seemingly outdated in comparison to today, was more than adequate for their needs. They built their design iteratively, gradually refining each element: the detonators, explosive lenses, uranium tamper, the plutonium core, along with the polonium-beryllium initiator. Each iteration boosted their confidence and understanding of the design, even as the challenge of predicting the outcome remained very difficult. By December 1965, the team had a preliminary design for a plutonium implosion device. The design was finalized in September 1966, accompanied by detailed blueprints for machinists. While their design was too large to fit on a missile, a reason for this was their conservative approach, focusing on ensuring a bang rather than maximizing the yield, an approach mirrored for the Trinity device. Upon submitting their report, Dobson and Selden embarked on a speaking tour visiting the CIA, the State Department, Pentagon, Oak Ridge National Lab, and Los Alamos. Their mission was to explain to government officials how they built their device. Reportedly, while most government officials were taken aback by their achievements, the scientists present at their talks were not. Interestingly, the duo was not officially informed about the theoretical test results of their design, but informal conversations hinted that their work was indeed a success. Post-experiment, both Dobson and Pipkorn pursued careers outside the realm of weapons development, but Selden remained. However, their work on the Nth Country Experiment left them with serious concerns about the relative ease of creating a nuclear weapon. As Dobson put it, "It's kind of a depressing thing to know that it could be done that easy. On the other hand, it's far better to know the truth." Back in the 1950s, there were two schools of thought: that the ideas could be kept secret and that the material could be locked up. Now, well, hopefully the materials can still be locked up, but we all have our doubts about that. It turns out, building the device is not overwhelmingly difficult. There are some subtleties that are not trivial, but an awful lot has been published. If you were a grad student today and you reviewed the literature, a lot of pieces would fall into place. Since the Nth Country Experiment in the 1960s, technology has progressed by leaps and bounds, invariably impacting every facet of life, including nuclear weapons development. Two critical advancements that have significantly altered the feasibility of creating implosion devices are CNC, or computer numerical control machining, and computer simulation. CNC machining is a manufacturing process that involves pre-programmed computer software dictating the movement of factory tools and machinery. It allows for 3D cutting tasks to be accomplished in a single set of prompts. Its precision, efficiency, and ability to reproduce intricate designs have significantly transformed manufacturing processes. In the context of nuclear weapons, CNC machining has simplified and expedited the process of crafting critical components, miniaturizing them, and manufacturing them to extremely tight tolerances. The precision offered by CNC machining ensures high consistency and quality of components, minimizing variability that could impact the weapon's effectiveness. As an example, this is one of the reasons why North Korea, with its limited resources, has chosen to focus extensively on the development of CNC machining tools. In general, things like CNC machining, micromilling, ion beam polishing, and measurement equipment have come a long way since the 1960s. Modern computer simulations have also dramatically changed the landscape of weapons development. Unlike the punch card computer that Dobson and Selden used, today's high-performance computers can run incredibly complex simulations, effectively modeling the behavior of nuclear weapons. Advanced computational physics now allows for the modeling of nuclear reactions, high explosive detonations, and the behavior of materials under extreme conditions. This ability to simulate reduces the need for physical testing and trial and error processes. Additionally, machine learning and AI have begun to play roles in nuclear physics, potentially further streamlining the development process. Heuristic algorithms can analyze vast amounts of data, recognize patterns, and make inferences, which could be invaluable in designing an implosion device. This is not dissimilar to how AI is being used in drug discovery and molecule analysis, but at an abstraction layer deeper. I decided to make a video on something non-financial just to make things a bit more interesting. By the way, if you do statistical analysis in Excel, you might want to check out a piece of software I write called Numerics. It allows you to turn Excel into an advanced statistical lab by giving me access to algorithms that don't come with Excel by default. Other than that, I hope you enjoyed the video today, and if you did, give it a thumbs up. I'll see you in the next one. Cheers.